Okay, a 1.5 kilogram trolley cart is connected to a cord by a 2.5 kilogram mass as shown. The cord is placed over a pulley and allowed to fall under the influence of gravity. Assuming the cart can move over the table unhindered by friction, determine the acceleration of the cart. Okay, so I'm just going to draw a quick diagram. There's our mass, there's our trolley. What were our masses again? What's the trolley? 1.5 and our mass? 2.5. Thank you. All right. First of all, let me ask you, will this system accelerate?
Yes.
Yes, it will. There is an unbalanced force acting on it. What is the unbalanced force? No, not the magnitude. What is the force? What's it called?
Gravity.
Gravity. Gravity is acting on this. The only thing that is going to accelerate this system is the gravitational pull on this 2.5 kilogram mass. Okay? Gravity has no effect on our cart because it's sitting on a bench top. Only the gravity on the 2.5 kilogram mass is going to accelerate this system. Okay? So let's work out what that force actually is. Force is mass times acceleration. So our mass is that 2.5 multiplied by 9.8 for gravity. So I get 24.5 newtons. Okay? So, are we happy with that? This weight is the only thing that's going to accelerate the system. So to work out the force on this system, we just work out the acceleration of that mass. Okay? All right. So, we want to determine the acceleration of the cart. Okay. So, what we need to think about here, do we agree that the cart and the mass are going to accelerate at the same rate? We're happy with that? Yeah, they're attached by a rope. Okay, if this goes down at this speed, the cart's going to go at the same speed. That's all fine. All right? So, what we need to consider here, though, is no longer are we accelerating a 2.5 kilogram mass. We have to look at this as one whole system now. Okay? Everything in this system is going to accelerate at the same rate, so we need to look at it all together. So what's the mass of our system?
3.
How much?
4.
4. 4 kilograms is our mass. So, we know the force accelerating the system is 24.5. Actually, let's just do it the other way. So we want acceleration. Force over mass. So our force accelerating the system is at 24.5. Our mass, oh, that's not right, it's 4, is the mass of the whole system. $6.125. Okay, we've got the acceleration of the whole system, which gives us the acceleration of the cart. All right, so there's a couple of different steps you need to do here. You need to work out the force that accelerates the whole system, which is the force from that mass, and then apply that force to the whole system. All right, next one. If a frictional force of 8.5 newtons acts against the cart, what is the acceleration now? All right, let's draw a diagram. What's accelerating the cart? What's the name of the force?
Gravity.
The cart, just the cart.
Tension.
Tension, all right. So we've got a tension force of, what is it, 24.5? And we have a frictional force of 8.5. And so we have a net force of 16 newtons. Okay, so if we apply a frictional force to our previous example, we know the force pulling it forwards, the tension force. We know it's got a frictional force now, so we can work out our net force, our total force, which is 16 newtons. So we get our acceleration now. A equals F on M. Our acceleration is going to be 16 over just the... Hang on. Yeah, it'll be the whole thing. You're right. Yep.
Plus, that gives you nice, easy.
Yeah, it does. That's right. Words to live by. Okay, so again, that force is accelerating the whole thing. So our whole system has a force pulling it forwards of 24.5 and a friction of 8.5. So we've got a net force of 16, a mass of 4, so that gives us an acceleration of 4 meters per second squared.